All right, welcome everyone to this session. This is called the Encryption and Transit for your Kubernetes applications. Just to introduce myself, I'm Ram Ramani. I'm a principal security solutions architect at AWS, focusing on data protection and privacy. And I have my colleague Divi here with me. He's a senior software engineer, the founding member of the AWS Private Certificate team, and we're going to be talking Kubernetes today. All right, so just before we get started, show of hands, how many of you are Kubernetes developers or manage Kubernetes infrastructure? Just curious. Okay, I can't see anyone here with the lights, but yeah, okay. All right, cool. A lot of you. That's good. So you're in the right session then, okay. All right, so let's kind of start with a basic Kubernetes cluster. This is probably all of you, or those who are familiar with Kubernetes, this is very familiar to you. However, if you go back to first principles, you have the control plane, you have various different components, and then you have the data plane, which is the nodes and the workers, and you have pods and containers within those pods that are running your Kubernetes workloads. And essentially, the control plane is managing these worker nodes and the pods and the containers. And you have some components, such as a kubelet within the data plane, which uses a pod spec and manages what actually gets deployed within these pods, as well as the health of these pods. It's very plain, simple Kubernetes architecture. But you may be wondering, if I'm operating on AWS, which is our managed offering called EKS, what is an equivalent architecture diagram look like? So if you, again, go back to the control plane and the data plane, the control plane itself is completely managed by AWS. So if you're familiar with the shared responsibility model, we take care of the control plane from a security and management perspective. But then you have the data plane, which again is the node and the pods and the containers. That is probably running on either an EC2 instance, if you want to manage the compute yourself, or you could be using serverless Fargate, right? These are the two options. Now, this talk is about encryption and transit. We're kind of dialing down into specifically encryption and transit, so that's why we are saying, let's say, what does terminating TLS looks like at some of the components of Kubernetes, in this specific case, ingress. So if you're familiar with Kubernetes resources, so you have ingress, and then you have a service, and then behind the service, essentially, your workloads are running in a pod or within a container within a pod. And we find that most customers are terminating TLS at the ingress. But the ingress itself is a resource, right? By itself, it's just a construct. It's a virtual construct. But then you need to have some kind of a controller, which you put on top of it, which kind of fronts the ingress. However, the TLS termination itself happens at the ingress. So that's one way to do it. Now, the second way to do it is you may say that I would like to have end-to-end encryption, not just at the ingress, but I also want to terminate TLS at the pod. And that's also possible, right? So you can either terminate at the ingress or at the pod. If you are not using this plain vanilla architecture that I showed you, and if you're dealing with Istio or a service mesh architecture with Istio, you may be potentially using an Envoy proxy for proxying all the traffic, and then Istio policies for defining which pod can talk to which other pod, or with allow and deny policies and all that good stuff. However, similar to the plain vanilla diagram with ingress and pods, even with Istio, you have these controllers, so where you have an Istio ingress where you can terminate TLS, or it could be at one of the containers that is running inside your Istio service mesh. You could terminate TLS there as well. In this diagram, as you can see, I mentioned about a controller, but here I'm showing you an example of a network load balancer, which is fronting the ingress, or the Istio ingress, or the Istio gateway, as they call it. Now, beyond termination of TLS at the ingress, you could have an AWS load balancer controller, right? And this is not the Nginx controller. This is a AWS load balancer controller. And what this allows you to do is that some customers say, hey, I would like to just terminate TLS at the load balancer. And there's some advantages to that, because AWS load balancer is a managed service, and as well as a lot of the certificate services that kind of integrate with AWS load balancer makes it easy for putting certificates on theirs. And I'm talking about X.5 runner certificates, just in case. So essentially, you can put these certificates, and they're managed and renewed automatically. So you don't have to do much. So few customers do that, but majority of the customers still terminate at the ingress, which is what we will focus on in this talk. But I wanted to bring it up here just so that you know that if you are going down the path of using a load balancer controller, you can leverage the AWS load balancer as well. It could be either the network load balancer or the application load balancer. Now, so I kind of set the stage for what we're going to do here, but let's just talk about what you can take away from this talk. This is a code talk, right? We're going to get into code and demos and all that good stuff. However, so we're going to focus on how to achieve encryption in transit for your EKS applications. You'll see that in depth. The AWS services that can help you do that. We'll get into developer tooling, the ease of use while providing the needed security. And then there's a GitHub sample that we will show you. And if you have brought your laptop, you can follow along as well. And that you can leverage right away. So the hope is that you can take that sample to your organization, and you'll find that it is really easy for you to achieve encryption in transit for your EKS applications. Just curious, I mean, I know some of you told me that you actually are Kubernetes developers or manage infrastructure for Kubernetes. How many of you kind of participate and go to KubeCon and are part of CNCF standards? Anyone here developing any? Few of you? So, okay, great. So, as you know, for TLS, you need certificates and certificate authorities, or essentially a PKI. Within AWS, we offer you a service called the AWS Private Certificate Authority, which allows you to create certificate authorities as well as obtain or issue certificates that you can put on at your ingress or at your pods or wherever you want to terminate TLS. So it's a completely managed service which kind of allows you to build your PKI needs. Now, getting certificates primarily uses the CSR model, as we call it. So pretty much you have a public-private key pair that gets generated somewhere, and then you generate a CSR out of that public-private key pair, essentially. The CSR itself contains the public key, and then it gets signed by the private key, and you get a CSR document, and you eventually send it to the AWS Private CA, and you get a certificate. Most of the services operate that way. For example, on the right, you can see, we're talking about EKS in this talk, but you could potentially use these certificates in load balancers. It could be hybrid. You're connecting from either other cloud providers into AWS or from on-prem into AWS. You could be using IAM roles anywhere with trust anchors that are using a certificate from AWS Private CA. And then, of course, if you're in the IoT space, you could put certificates there as well. So all of these follow this concept of essentially the CSR, and then you issue a certificate with a certificate authority. And in the Kubernetes world, I showed you EKS, which is our managed offering, but we see customers on-prem with their native Kubernetes applications as well leverage certificates from AWS Private CA. So you could do that as well. So as long as you have the ability to connect into AWS and issue a CSR, you can get a certificate. So what is this Private CA, right? So Private CA, as I said, it is a managed service, and it allows you to build CA hierarchies. It could be a root CA and a subordinate CA, or you could have multiple different hierarchies where you have a root and multiple subordinates, or a root, subordinate, and issuing CA. But whatever hierarchy that you need based on your risk profile, you can build that. And alongside that, the good thing here is that it's a one-click operation, or you can use infrastructure as code and pretty much set up the necessary certificate parameters and the signing algorithms for the private and public keys, and then you're good to go, right? You're able to essentially have a completely managed certificate authority which can do CRLs for you, or you can do OCSP depending on your revocation needs. And then at the end of the day, it is a RESTful API call of issue certificate with which you can issue certificates. And just like any other AWS service, it's pay-as-you-go pricing. And we also have certificate templates where you can customize certificates. It could be you could be generating a code signing certificate. It could be whatever you need, right? So essentially, it's very customizable using something we call as the API proxy method, where you can actually send in parameters and you can customize the certificate based on whatever template you choose to do or the functionality of the certificate itself. And as I gave you an example of code signing, but there could be others as well. Now, these certificate authorities, they're managed centrally, but they can also be shared across accounts if you desire to you can use something called as the resource access manager, and you can share it out between accounts. If your workloads, for example, are spanning multiple accounts, but you would like to use the same certificate authority, you can share that as well. That's also possible. All right. So we talked about Kubernetes developers, and if you've ever been to KubeCon, there's always a talk about multiple tools being developed by Kubernetes developers. So if you ever go to KubeCon, there's a lot of different tools coming up which are solving various kinds of problems. And the tools and the ability to use them securely and effectively are the means for you to have a mechanism for your EKS or Kubernetes applications to achieve encryption in transit easily, where security itself dissolves under the hood, and you as a developer are focusing on actual user experience and application value, right? We want to make sure that security becomes very easy. And in this case, my colleague Divi is going to show you how this tooling comes together to make it easy for you to achieve encryption in transit for your EKS applications. So Divi, over to you.
Hi, everybody. I'm Divi. Y'all can hear me, right? Oh, OK, cool. I'm Divi. I've been with AWS Private CA for 8 years now. And Ram's talked a lot about the theory and how all this comes together and where we're going with encryption in transit. I'm going to talk a little bit about tooling. Consider me your engineering guide as we go through these demos. And I want this to be a little bit interactive, so if anyone has any questions, let me know. I do have stickers that I'll give away, EKS stickers, if anyone asks some good questions. I think the next step here is we're just going to go through these tools and talk about what we're going to use as we build up to encryption in transit. So first tool we're going to talk about is Cert Manager. There's a really good chance that you're using Cert Manager today if you are using Kubernetes at all. I like to call it the de facto tool for certificate management. It makes it really easy to manage your certificates, manage renewals, and you also have plugins that go into Cert Manager. So AWS Private CA is something we've talked about. AWS Private CA can be used with Cert Manager as the certificate issuer and the CA. So we have an add-on for that we'll talk about in a second. Now, the next tool is EKS CTL. This is very similar to kubectl, except you can use it with your EKS clusters. And there's some sub things under that. One of them is pod identity. So if you have a pod that's running on your cluster and you need to get access to an S3 bucket or DynamoDB or something else in your AWS boundary, then pod identity is just a tool that lets you do that can be set up with EKS CTL, and it'll actually give STS or IAM credentials to your pod. The next tool is add-ons. So EKS has this idea of add-ons where before you would use something like Helm or some other package manager or your own manifest files to deploy whatever software you needed to your Kubernetes cluster. With add-ons, it's one-click go. You can run one CLI command, one-click install a lot of different tools, including Cert Manager as well. And the next thing that EKS CTL lets you do is cluster creation and management. All right, so the next tool is Istio. So this is something that Ram covered in one of the previous slides, but there's this idea of a service mesh. Service mesh made easy. It's a single place that you can go to have all of your networking policies, throttling policies, manage all your mTLS rules, all those sort of things. And we're going to use Istio in one of the demos, the second demo, to actually enable mTLS and make sure that pods are talking to each other with mTLS. The next tool that we're going to use is just an Nginx ingress. We talked about ingresses already, but this is just going to be the specific controller we're using is the Nginx variety of the ingress. All right, and so we talked about add-ons real quick, and we talked about how Cert Manager has plugins that you can use. So one of the things we're announcing today is the EKS add-on for Private CA Connector for Kubernetes. This is just an add-on where you can one-click install a piece of software that will work with Cert Manager in conjunction with it to issue certificates through Private CA. This is really useful to simplify your certificate issuance and management. It works in conjunction with Cert Manager, which you're probably already using. And you can install and update this add-on with seconds. In automation, it's pretty simple to use. All right, just to show you a little bit how that connector works, it's just, like we said, it bridges between Cert Manager and AWS Private CA. You can issue certificates to things like your service mesh or your ingress. It's just an architecture diagram that kind of walks you through that. All right, time to get into the demos. So the first demo that we're going to do is going to be terminating TLS add an ingress. So this one is pretty straightforward. We'll go to the architecture diagram. You have a load balancer. With that load balancer, you're trying to traffic hits the load balancer, goes to your Nginx ingress. Your Nginx ingress requests a certificate from Cert Manager, and Cert Manager reaches out to AWS Private CA, gets that certificate, puts it on the ingress. So TLS termination is happening at the ingress. So in this case, if you have a client that's trying to reach, you have a service that's running on your Kubernetes cluster, and you have a client that's trying to reach it, then you will have TLS encryption between the client and the ingress. So let's go and do a demo of that.
With the QR code.
Yeah. And so let me switch over to the next laptop. OK. So just to show you, we do have a AWS sample. And this AWS sample is going to be something that we're going to go through for all the installation here. So all the steps we do, everything is part of this sample, and it gives you a series of like very easy to use scripts that you can take home, use with your organizations or just at home. And you can set up core PKI tooling, you can set up AWS Private CA, you can set up ingress, mTLS, Istio, do all of that through the sample. And we also have this QR code. I'm going to leave it up for like the next, 10 seconds. If you are interested in following along, I will say some of the scripts that I'm going to run take some time. So I've like pre-run some of them. But you can scan the QR code, and you can go to that GitHub page and run some of these scripts yourself, follow along, see how you like it. And I'll put this QR code up at the end as well. It's part of our presentation. Cool. So this is the AWS sample that we're going to follow along with. And all I did is I went here, I just cloned it, and I have it here now. And one of the commands that I run is I create cluster.sh. I'm not going to run it here because I've already created a cluster. Creating a cluster takes about 15 minutes, so I'm not going to put everyone through that. But I'll show you back here. So this is my AWS console. And if I go to EKS, running that script gave me this EKS cluster. And one of the add-ons that was installed as part of that script was also this pod identity agent. So we talked about pod identity a little bit earlier. So this is just the concept of I have a pod, I need IAM access for that pod. How do I do it? This pod identity agent will help you. So one of the things the script does is installs that for you. All right, so I won't run that script, but we'll go to the next one. So what else do we have here? We have deploy core PKI. So this is the next script that I'm going to run. This script is going to do things like it's going to install Cert Manager. It's going to create an AWS Private CA hierarchy for you. It's going to set up pod identity to make sure that Cert Manager has the ability to actually get that certificate. And then it's also going to use that new EKS add-on that bridges the gap between Cert Manager and AWS Private CA. It's going to do all those things. It takes a little while to run again, so I have pre-run it, but I'm going to run it again here. And then while it runs, I'm going to show you some stuff in the console and what's actually going on. So this is running, and while it runs, we can head over to the code and just take a look at what it's doing. So this is the code. I think it's big enough. Yep, this is the code. And this just takes in some parameters, cluster name, region, et cetera. And one of the things that it does is it sets up this pod identity association. So this pod identity association is for a tool called ACK. So we haven't talked about this yet. ACK is a tool. You can think of it as, I like to think of it as CloudFormation or Terraform for Kubernetes. But ACK is a tool. It's Amazon controllers for Kubernetes. There's an ACK controller for S3, for IAM, and also for AWS Private CA. It's a tool that lets you deploy via manifest, infrastructure as code, and deploy an AWS Private CA hierarchy. So what's happening here is I'm going to deploy ACK, but deploying ACK requires the ability for the controller to access AWS Private CA and use this IAM policy. And that makes sure that it has the ability to actually create the CA hierarchy. So here we install the pod identity association. And then next we use this Helm command to actually install the ACK plugin itself. So this Helm command installs ACK for Private CA. And just to skip ahead a little bit, I'll show you this is the hierarchy that it's going to install. So this hierarchy is going to have a certificate authority. It's going to have a certificate to activate the certificate authority. And it's going to have just an activation resource that activates the certificate authority and gets it ready to use. And then later we'll use it with, we'll use the CA with Cert Manager to issue more certificates that your cluster can use. So this is the hierarchy, going back to the script. So yeah, here what happens is once we've Helm installed the ACK plugin, we go ahead and apply that manifest file where we say the private CA hierarchy, please give that to me, and ACK does. And you get a CAR out of that. Next, we install Cert Manager. Cert Manager, again, very popular tool. And you can do this through add-ons. So just to show you the difference, like if I'm installing something with Helm, It can get to be a very complex command. Like, take a look at this command. It's a lot. But if I'm using EKS add-ons, a lot of that is done for me. One simple command right here. And this EKS add-on is going to install Cert Manager for me, and it just makes it very easy without all the extra configuration that you often have to do with Helm. Next, I'm going to just do some basic namespace creation, and I'm going to create another pod identity association. And this one is going to be used for the connector for Kubernetes. So this is the next add-on that we're going to install. And this connector for Kubernetes is going to be used to, again, bridge the gap between private CA and Cert Manager. But you need IAM permissions to do that, so that's what this pod identity association will do. It gives like permissions like issue cert, et cetera. So that gets done, and then we create the add-on right here. So here, again, very simple one-line command to create the add-on for the AWS Private CA connector for Kubernetes. And that's it. So that's what this is doing. This is it's just setting up all the infrastructure that you're going to need, all the tooling, et cetera, that you're going to need to actually set up the rest of the demo. So that's what we have here. And one last thing I'll show you is this also deploys this Cert Manager issuer. So this is going to be the issuer that we're going to use for the rest of the demo. And so when we created a private CA, earlier using ACK. The CA ARN will end up here, the region will end up here, so that later when we issue certificates to the Cert Manager, it comes through private CA. Cool, so that's the first script. And you'll see here that the script is done. And again, this is just the script that's part of the GitHub demo or the GitHub sample. And if I apply this, it'll, well, again, because I did it earlier, but it'll create the certificate. And we can actually take a look at that certificate by just describing it. And we'll see that the certificate is ready, and you can also export it into a cert.pem, and then I can use OpenSSL to crack open that cert. So this is the certificate that I just deployed the certificate just to show that like the tooling is working, and that we were able to issue a certificate, and it's just example.com. Cool. So that is the first script that I run, and we can clear that out. And the next script that we're going to run is actually going to set up the demo one, which is with the ingress. I'm going to switch back so you can see the architecture diagram one more time, just to remind you what we're setting up. So this right here is what we're going to set up. Again, it's just an ingress, and then we're going to deploy a certificate to that ingress and do TLS termination at that point. So moving back, do the demo. OK. Yeah, I'll show you the IAM policy that's being used. So actually,
so you saw the pod identity where we are able to create the pod identity association with a specific role for permissions within AWS to do certain actions. So what Divi is going to show you is that the permissions itself, what is needed so that ACK can actually do these actions within AWS, right, for private CA issuance or issuing private certificates.
Yeah, so I used a managed policy, and just to show it to you in code, this is the policy that I set up. The policy that I set up was this one right here, the AWS Private CA connector for Kubernetes policy. So I showed it to you here, but I'll show it to you in the console as well. Or actually, if I copy this, it should show up. There it is. So this is the policy. So this is the policy that's actually being used with pod identity. It just has basic describe certificate authority, get certificate authority, and issue, most importantly, get issue certificate authority, or issue certificate. All right, so back to the demo. OK, so now I'm going back to deploying the ingress. So deploy ingress. And I'm running this. Again, it takes a little bit of time for the load balancer to come up. It takes maybe like 5-10 minutes sometimes. So this is something where I'm running it here, and I'll walk through the code, and then we'll take a look at the console. So let's go to the ingress and look at the code. All right, so same script. In the beginning, we're just taking in some parameters. And next, we just do some installation. So we install the Nginx controller. So this is just the ingress control that we've been talking about. It'll deploy Nginx to your cluster. And then when the Nginx controller is installed, one of the things that it does is it actually spins up a load balancer on your behalf. And so we give it permissions to actually be able to do that. So we give it this policy, the Amazon EKS load balancing policy. And this policy contains a action that says, yeah, this cluster can, or this pod can create a load balancer on my behalf. And so we do that we do the pod identity association here, and then we install Nginx here. And notice one of the things we explicitly tell it during the installation, create an NLB for me. So that's how the NLB is created. And that's really the majority of the script. So the script is really just setting up that Nginx controller, giving it IAM permissions to create an NLB for me, and then it's going to just do one more thing where it deploys like a demo app. And this app, not fancy, it's just a deployment that running Nginx, and we're going to take a look. And one of the things that it does, by the way, is when it creates the ingress, it calls out to Cert Manager in one of the annotations. So in the ingress, it calls out to Cert Manager and says, hey, that issuer that we created in the last step, give me a certificate off of that issuer. So I'll show it to you again. The issuer that we created in the last step was this cluster issuer. And we actually refer to it again, and we say, give me a certificate, and this cluster issuer is set up to use AWS Private CA through the CA ARN. So that's how the Nginx controller is actually injecting, or Cert Manager is injecting a certificate into the Nginx controller. So that's what's happening there. And now if I go to the console, and I go to the load balancer, wait, that was weird. Let's go to EC2. There we go. And here, if I go down to load balancers, and you'll see that a load balancer was created. And again, I didn't do this through any sort of like CLI command or anything. This was all done through Kubernetes, where a load balancer came up. And this load balancer, if I go to it and actually hit it, it's going to say it's not trusted, and that's because I'm using a private CA, so that's not like natively trusted. I would have to add that certificate to my trust store. But I can hit advanced and proceed, and it works. Like I can hit my Nginx controller, and it says welcome to Nginx. So the communication that I did is encrypted, just not trusted in this case. I would have to add it to my trust store. So that's the first demo. And actually, I'll show you one more thing in it. I have some commands here that will show you the certificate itself that's being used. So this is me just grabbing the certificate that's on the ingress and taking a look at it. So this certificate is what's actually on the ingress, and you'll notice that in the SAN you have the DNS for the load balancer that we just hit. So this is just what the certificate looks like.
Can you show them the trust bundle from download from the Certificate Authority?
Yeah. So I think Ram is asking, how would someone actually do the whole thing where I want my browser to trust it? So I can go to the AWS Private CA. And so again, by the way, this is something where this AWS Private CA was not created through some like external command, all done through that script earlier where ACK set it up for me. So here you can go to the CA certificate. And this right here is the CA certificate that you would want to trust, or your browser would want to trust. So you can export it and then import it back into your trust store. So that's how you would do it. Cool. So that was, I'll switch back to the slides real quick. So that was the first demo. And now we're going to talk about the second demo. So this is really end-to-end now. We're talking about, as someone pointed out, we're talking about doing the encryption all the way through to your pod that's actually serving traffic. So what that looks like is a little diagram. This is kind of like a simplified diagram of how it looks. So you have your external client that's going to reach out to your NLB, which is similar to what we did before. And this time it's going to pass through all the way to your ingress. Your ingress is going to do an initial TLS termination, and then it's going to get re-encrypted, and it's going to go through your service, and now it's going to be mTLS all the way to your, we call it just hello pod. It's just a hello world pod. And one other thing to point out is that communication happening between pods, so you have that client pod and that hello pod, that communication is also going to use mTLS. All this is done using the same tooling that we talked about, plus we're adding Istio now to help set up some of these policies and use a service mesh. Cool, so let's go ahead and do that demo. So again, using the GitHub script that we had before, clear, and we can go and deploy mTLS This is the script. And while it's running again, we'll talk about what it's doing in the actual script. All right, so this script starts out the same. You have some parameters coming in.
Oh, you just switched the thing, yeah.
Oh, thank you.
Sorry, thank you.
Thank you. OK, so I'll just say it again. Terminal. In the terminal, I ran this script. Or I'll find it. Yeah, I ran this script. And while that script was running, I'll run it again. It doesn't hurt to run it twice. While the script was running, I'm just going to talk through exactly what we're doing in code. So the script starts out the same way. And here we create a pod identity association. And this was one that we saw it on the console earlier, but this is one for Istio. Istio itself will create a load balancer. So this is just giving Istio the permission to do that. And so this is the load balancing policy. And next, what we do is we deploy this Istio Cert, which I'll open up. And this Istio Cert here is going to be, it says isCA is true. This is going to be used to actually get the get certificates later, issue certificates later that are going to be used for mTLS. And so one of the things we do here is we create this Istio CA key pair secret where the key and the key information is stored. And so when we go back to our script, you'll see that when we install Istio, we actually pass it that key pair. And we say, hey, use this as your key pair for your CA. And that certificate itself, by the way, going back to it real quick, that certificate itself roots up to AWS Private CA. So if you go down to the issuer ref, this is the same issuer that we used in the example before and in the first script, which is the AWS PCA cluster issuer. So it's going to root up to Private CA each time. And what we do next is we issue the gateway cert. So if you remember, switch back. In the diagram, we actually do termination at the gateway. This is the certificate that I'm issuing here that will give me the gateway cert. So switching back. Yeah, so this is the certificate, the gateway cert. And you can see it in gateway cert.yaml. So that's the certificate. And again, notice how that roots up as well to the AWS Private CA issuer. So this is also a certificate that's being issued off of that AWS Private CA. OK, and next we deploy the gateway. And so this is, you remember from the diagram, we had the gateway where we're doing the termination. So this is the gateway itself being deployed. That gateway is just configured. You see that it says TLS mode, and we just say simple TLS. This is not mTLS, because this is the client authentication coming in. And so you have the hello TLS secret, which is the gateway cert secret. So if we go back to the gateway cert, hello TLS secret. So the gateway cert gets issued through Cert Manager off of an AWS Private CA. It's put on the gateway. Termination happens there. And you can see that all in code right here. And one of the things we do as well is we set up a destination rule that points to a service. And this service itself is using just a pod. That's just a Hello World pod. And you can see that in the demo app. So you have this deployment, service. And we also deploy a pod that has this curl command in it, so we can use it to show later, like, is mTLS working in between pods or not? So let's go back to our script. So we deploy the demo app that I showed you. We also have this file called PR authentication. I'll open that up. This here is actually saying mTLS for anything that's inside the Istio namespace, or the Istio system. And so here you have strit. And we're saying mTLS for everything. All right, so we deploy the pods. And if we go back to the command line, you'll see that it does a couple of tests at the end of the script as well. It kind of auto runs them for you. One of them is it's testing that mTLS was working. So just to go back to the diagram, you'll see those two pods that are talking to each other at the bottom, and it says mTLS. So it's testing. Does that mTLS work? So it runs this command, and it tests, is mTLS working in between those two pods? And that should succeed, and it does. So it does. It works. And you know that because it says it works. It actually returns that from the pod. And next, we test from outside the mesh. So one of the things that I did is, as part of the demo app, I deployed this extra pod. This extra pod is running outside of the namespace that I said all of the communication needs to be using mTLS. So here I said test mTLS, which is a different namespace. And this is just deploying curl. And so this test, what it does is it actually tests that mTLS is, the connection is failing because there's no mTLS. And it does fail, so that's good. And the next thing is we can just test that we can hit that endpoint. So if we go to the load balancer, similar to what we did earlier, or go to EC2. Go to the Istio. So this is the load balancer that was generated from this script. If we go to that DNS, same thing as before, where you would actually have to go to the AWS Private CA, download the CA certificate, and have your browser trust it. But otherwise, you can go, and it says it works. And so now what's happening is when I hit this load balancer, again, it gets terminated at the TLS, and it goes all the way, mTLS goes all the way to your pod that's actually serving traffic. So it's encrypted truly end-to-end this time, not just terminating at the beginning of your cluster. Yeah. Yeah. The listener protocol.
Can you repeat the question?
Is it listening on port 80 to accept unencrypted traffic, or is it going to force it to port 443?
It does a redirect. Yeah, it's redirecting to 443. Any other questions? Okay, so one thing I'll show is the certificate itself. So actually, one thing I haven't shown is these are some of the pods that are running on the cluster. So you see you have ACK pod, you have the issuer itself. This is the AWS Private CA issuer, also known as the connector for Kubernetes. We have Cert Manager, which works with that connector. We have the Nginx controller. So one thing that I'm going to do is I will actually grab the certificate that is on one of these pods, and we'll take a look at it. So these are just some commands that I have that lets me grab that certificate. They're a little bit hefty, but we can use OpenSSL at the end to look at that certificate. So this is a certificate, for example, that's in one of those pods, and you'll look at the, let's find the SAN, there it is. In the SAN, you'll see, so this is, Istio actually uses SPIFFE under the hood, or some set of SPIFFE specs under the hood, and you'll notice that Istio gave a certificate to the pod that says this pod is in this cluster under this namespace, which is the Istio demo namespace that I created as part of my script, and that pod is running as part of this service account, which is just the default service account. So that's what the certificate actually looks like that's being used for mTLS.
Actually, we also see a few customers connecting from pods which are on-prem, which have SPIFFE identities into AWS. If you need that, that's also possible. We have something called IAM roles anywhere, with which you can connect into AWS from other cloud providers or from on-prem with credentials.
I'm going to switch back to the slides really quick. Yep, okay.
Yeah, the slides, yeah.
So this is just the architecture diagram what we created. So again, we just created a gateway, termination of the gateway, mTLS all the way through after that. This is, I showed you this earlier, but this is the QR code if you want to try it, take it home. All these scripts are available, all the tooling is available on that GitHub page. So take a picture if you want, or scan the QR code. It's all on GitHub.
And we go back to the slide.
Yep.
So this particular sample which we built recently, it's got, as Divi showed, it's got complete automation of building the certificate authority with code and deployment, both for your gateways, or it could be your ingress, or it could be on your pods. So really, it kind of melts away the security components and makes it very developer friendly with as less code as possible and very simplified commands. So if you're trying to deploy, like essentially satisfy the need for encryption and transit for your Kubernetes or EKS applications, this sample can right away do it and makes it very easy. So if you're trying to deploy this and if you have any questions, next slide. Yeah, sorry. Please reach out to us, and if you see that there is anything that's not working or you need more help, feel free to reach out to us through LinkedIn, and we can connect later on and go deeper into what you're trying to achieve. So that's all we had for you. Thank you so much.
Thank you.
Yeah.